Hello friends, welcome back to Knowledge Station.
Ever wondered why a ball keeps rolling until it hits something, or why you lurch forward when a car suddenly stops? Well, the answers to these intriguing phenomena lie in the heart of Newton's laws of motion. Newton's first law, often referred to as the law of inertia, tells us that an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by a force. Picture a book on a table. It's not going to move unless you push it, right? That's inertia in action. Moving on to the second law, force equals mass times acceleration. This law explains how the velocity of an object changes when it is subjected to an external force. Consider a small pebble and a large rock. If you apply the same force to both, the pebble will accelerate much faster than the rock. Why? Because the larger the mass of an object, the more force it takes to change its motion. Now, let's delve into Newton's third law, the law of action and reaction. This law states that for every action, there's an equal and opposite reaction. Ever jumped off a small boat and noticed how it drifted backwards as you leaped forward? That's Newton's third law at work. So, to recap, Newton's laws of motion explain why objects move the way they do. The first law, the law of inertia, states that an object will stay at rest or keep moving at a constant speed in a straight line unless it is acted upon by a force. The second law, force equals mass times acceleration, tells us that the force acting on an object is equal to the mass of that object multiplied by its acceleration. And the third law, the law of action and reaction, says that for every action there's an equal and opposite reaction. These laws, first documented by Sir Isaac Newton in the 17th century, continue to be fundamental principles in the field of physics. They help us understand everything from why we don't fly off when the Earth spins to how rockets propel themselves in space.